Hey guys, welcome to Epi Explained episode 2. Last week we discussed the definition of epidemiology, and this week we're going to be delving a little bit deeper with the discussion of mortality and morbidity. Before we get started into the measures of disease burden, let's briefly discuss a recurring concept in epidemiology, which is the difference between rates and proportions. Rates allow us to determine how fast something is occurring, such as the rate of a flu spreading through a town filled with preschoolers, which is probably going to be pretty high, right? Proportions, on the other hand, give us an idea of the number of people actually affected. We can think of this as a head count at any given moment. The first measure we'll look at today is called prevalence. It's defined as the number of both new and existing, or in other words, the total number of cases within a given time period, divided by the total population within that time period. If you didn't already notice, prevalence is a proportion and gives us a good idea of disease burden within a population. It, however, does not provide us with information about its risk. There are three main types of prevalence. The first is point prevalence, where only a single point of time is being looked at. The second is period prevalence, where a period of time is being examined. The third is called cumulative prevalence, where only cases having occurred up until a certain point are looked at. A similar measure is called incidence. It is defined as the number of new cases that occur within a given time period, divided by the total population within that time period. Because we're only looking at the new cases, this ultimately lets us look at how quickly a healthy person transitions from the denominator, or the total population, into a disease state, or the numerator. In other words, incidence easily gives us a measure of disease risk, and because of this, the words rate and risk are often interchanged in epidemiology. There are two main types of incidence that can be calculated. The first one is called cumulative incidence, where those who are healthy are able to be followed or observed for the entire duration of the predetermined time period. The second is called incidence density, and this is utilized when those who are at risk are not always followed for the entire time period. Calculating this type of incidence uses something called person time, where each individual's time spent being followed is summed to create a total person time unit for the denominator. A special type of incidence is called attack rate, which allows us to look at things like foodborne outbreaks. We'll discuss this in more detail in later videos. Complementary to measures of morbidity are measures of mortality, which are important because they can help us understand the risk of death from a given disease and can thus help us express disease severity. Additionally, when the disease is rare enough and deadly, mortality can be used in place of morbidity rates when death occurs faster than it is possible to gather information on incidence rates. Mortality rates are usually calculated similarly to how morbidity rates are calculated, in that you place the number of deaths or events in the numerator in the population you're looking at in the denominator, except in certain situations in which we'll see next. We can look at general mortality rates, or we can look at something called cause-specific mortality rates, where we say the numerator and the denominator are both restricted to the population, age group, disease, or time period we're interested in looking at. Both of these can give us an idea of the amount of risk a population is at for dying from a given disease. Conversely, proportionate mortality and case fatality can be misleading in their names. They are not measures of risk, but both measures describe frequency or proportion. Proportionate mortality is just as it is termed, the proportion of deaths from a given disease divided by the total deaths in the population. On the other hand, case fatality is another important measure of mortality in that it is more often used for fast-acting diseases. Comparing two or more populations in terms of mortality becomes different when age comes into play. Because age can affect mortality or survival if you want to look at the glass half full, comparing a group of 10 to 15-year-olds to a group of 80 to 85-year-olds will not lead us to a valid result. To fix this problem, we can create an artificial rate or risk through a process called adjustment, which comes in two types: direct, which uses a standardized population, one that suits either our research needs or energy levels at the time, and indirect adjustment. We'll cover direct and indirect adjustment in future videos so we can look at it in more detail.
There's a high-density molecular process involved in this bonding agent.
It's a sticky situation.
Good one!
Thanks.